Hello, and welcome to this masterclass on turning vision into deliverables, enabling AI at scale. My name is Waqas Ahmed, and I'm analytics architect at Ahmed, Belgium. Outside my work, I'm a photographer, a reader, and a cricket player. AI has been termed as a new electricity. However, not many organizations have been able to take full advantage of it so far. A lot of data scientists have been developing and experimenting with machine learning and AI methods and techniques, but according to a report, only 22% of companies have used machine learning and taken a model into and deployed a model into production so far. When asked 750 machine learning and AI practitioners that how much time it takes to deploy a model into production, half of them answered that it took them between a week to 3 months to take this model into production. 18% of them even stated that it took them more than 3 months to really integrate a model into business applications. When asked data scientists that how much of their time was spent in deployment, at least data scientists' answer was that at least a quarter of their time was spent in making their model production ready. The main challenges that are identified in productionizing an AI models include the scale, because often taking a proof of concept model and scaling it to be able to integrate with the applications needs a lot of rework. Data scientists may be using different sets of technologies that are not available in the operations environment. Another challenge that concerns interoperability and the interpretability of the models is with regards to the version control. Reproducibility is another challenge. Achieving the deterministic training is an important characteristic of machine learning models, and it's hard to achieve it when it is residing in the production environments. Collaboration and involvement of data science and application developers together to take the model into operations is also one of the identified challenges. As it can be seen in the figure on the screen, that only a fraction of machine learning system is composed of machine learning code, and it is surrounded by a lot of infrastructural requirements, and these are the building blocks that are required to make a machine learning code work into production. All of these blocks introduce a lot of technical depth that needs to be managed when machine learning code is running in production. We can see a typical AI or machine learning development workflow on the screen, which begins by problem definition, which is done together by the data scientist and the subject matter experts. Then the data scientists start preparing the data. Then they extract some features, they do the model training, they evaluate the model, and if they are not happy with the results, the iteration begins again. This iteration produces multiple models, and out of which a final model is selected. Once the final model is ready, available, and it can go to production, this model needs to be handed over to operations team, which could set up the environment, deploy it, and start monitoring the application, which is actually consuming this model. However, data scientists and the operations team do not work in collaboration. So there is a huge gap between these two teams. This gap sort of introduces a so-called deployment wall. And for a machine learning model to cross this deployment wall, it needs to be reworked. And by rework means that it needs to be recoded in a language or the programming constructs available in the production environment, in the operations environment. And this also means that once the model is reworked upon, it needs to be retested for the coding. It needs to be retested for its accuracy, and it needs to be retested for the integration with all other components. Furthermore, once a model has been operationalized, it could easily become stale, meaning that in a machine learning model, anything could change anything. And often a retraining of a deployed model is required. These changes could be change of the problem definition, change of the data, change of the model requirement itself, or change of the code, to name a few. So from this, we could conclude that a different approach is required to bridge the gap between the development and operations teams. Software development processes have combined development operations in the form of DevOps. It allows them to automatically build, test, and monitor their applications. Machine learning models development process can also benefit from the same approach, and combining the development and operations of machine learning models is called MLOps. MLOps is similar to DevOps because building a model is similar to building an app. Validating a model is similar to testing an application, and deploying a model is similar to releasing a piece of code. And monitoring a model is also similar to monitoring an application in production environment. However, model retention is an additional step involved in this whole process because machine learning models could change once they are even in production. Some additional benefits of MLOps include creating and retraining the models automatically. Automatic machine learning pipelines can automatically version the data and the code that is being pushed into production environments. They can create a repository and a registry of the models to store them at a centralized place. They can also record the metadata of all the experiment runs to ensure integrity and conformance to regulatory requirements if needed. They can set the environment automatically, and they can validate the packages and also be used to perform the A/B testing if required. Finally, model monitoring and retention can also be performed automatically, where events such as data drift could be detected and a whole training cycle is restarted. So now that we have a basic understanding of MLOps, we can see it how it helped one of our customers in achieving and optimizing their model deployment workflow. In this slide, on the top, you could see that data scientists had to go through a series of steps to be able to deploy a machine learning model into production. These steps included first identifying the right data, then requesting the right data, sourcing the data themselves, and then start building their model. Once the model was built, they were involved in testing the minimal viable product in a manual way. And then once they were able to ascertain the value of their model, they had to coordinate with the operations and middleware teams to take their pilots into production environment. And to take the model into production environment, they had to cross the deployment wall, meaning that they had to rework on their model. And once the model is in production, they had to spend effort in monitoring their model to assess the real business value and start monitoring the incidents in production. However, when we spoke to the data scientist, their wish list included that they wanted to focus more on the science part of their job. That's where they have most fun. And then they wanted to be better at software development practices so that they do not have to rework their code and they are writing from the day one a production-ready code. They wanted to have a clear route to go live. We want to deliver solutions faster, and they want these efforts to be supported by the technological platform they were using. They wanted to achieve sort of standardization and wanted to leverage the best practices in the form of templates, which could make it easy for them to do the right thing and stop them from doing the wrong things. They wanted to reduce their effort on the operationalizing their model and still wanted to keep the ownership of the code and the model that they have produced. So, after interviewing the data scientist and the involved stakeholders, 5 key challenges were identified in this approach. The first being data was living in silos and data scientists have to go and tap these silos themselves. Data scientists were unable to collaborate and each one of them was using a tool of their own choice. This really made it difficult to standardize the model development practices. Engineers had to redo the work to cross the model deployment wall, and even they had to collaborate with 20 resources at least to be able to assess the impact of their MVP. Iterating over the model was also manual, and it took them a lot of time. Individually monitoring the solution and following up of the task was also one of the challenges and was taking a lot of time. So, we supported the data scientists and machine learning practitioners with the ML workflow techniques, tools, and the right services so that they could collaborate, build, test, release, and monitor their solutions in a streamlined fashion and as much automatically as possible. They were even provided with the capability to plan and track their work as well. By enabling MLOps practices, the deployment time for a model that was taking over a month was reduced to 7 days. So our key takeaway from this case study were that we need to enable the data access for our data scientists. Timely data access of the right data can enable AI to deliver value. Also, it's important to embrace the automation and the principles of ML ops. So collaboration between data scientists and operations teams, software design best practices, and automation of repetitive tasks can really help you accelerate deriving the value from AI and machine learning. Also, managing the technical depth around the machine learning codes and models and taking this responsibility away from data scientists could also help them take their models to production more rapidly. Last but not least, provisioning the right tools for data scientists help them to work in a standardized environment, and they can focus more on the science part of their job. So ladies and gentlemen, this brings me to the end of this masterclass, and I remain at your disposal in case of any questions.